Intermediate Algebra for Statistics, Modeling with Quadratic Functions. Lesson objective: use a quadratic model to make estimates and predictions. Lesson objective: Example 1. Airlines originated frequent flyer program in 1981. The cumulative unredeemed miles are the total number of frequent flyer miles that members have not redeemed spent from 1981 through a specified year. See table. Let C be the cumulative unredeemed miles in trillions of miles at T years since 1980. So this data starts at 1986. So in this case T is 6, T is 8 here, so on and so forth. This will be our independent variable. Our dependent variable is the unredeemed miles in trillions. Number 1. Find a model to describe the situation. Use a linear, quadratic, and exponential model. From these three, we will pick out the best model for this situation. Number 2. In what years is there a model breakdown for certain? Number 3. Graph the function. Number 4. Predict the cumulative unredeemed miles in 2010. Number 5. Predict when the cumulative unredeemed miles will be 25 trillion miles. Solution: we first need to put the data in and make a scatter plot. T will be list 1 and list 2 will be the miles. We turn the stat plot on. We hit second y equals. Make sure it's on. Make sure we have our scatter plot. Our X list is list 1. The Y list is list 2. Then we hit zoom and number 9 for zoom stat. And here we have the graph of the data. Okay. For the linear regression model, we have the slope being about 0.72, the y-intercept being a negative 6.4, and the value of R square is about 0.89. This is a visual. The linear model does not look like it's fitting this data very well. The data has a curve to it. Let's do the quadratic. For the quadratic, R square is very high, 0.995. So again, the closer that we get to 1, the better. This is very close to 1. Visually, we can see that the quadratic is doing a lot better job than the linear modeling the data pattern. C for the exponential, R square is 0.936, so this is not as good as the quadratic, and we can see that the exponential model is growing faster than the data pattern. So since there is a bend, the linear is not a good model. The exponential model is this one, the quadratic model is this one, and both R square and the picture, the quadratic model is a better fit. So that's the one that we're going to use. So we say Q of t equals 0.047 t squared minus 0.77 t plus 3.5 is the model for this situation. Number 2, we want to find the vertex first. So if you recall, the formula is negative b divided by 2a. So this gives us approximately 8.19. Evaluating 8.19 and the function gives us a value of about 0.35. So we would say that the model breakdown will occur for years before 1998, because the vertex is a minimum here. To verify this using a graphing calculator, we can hit our table feature and we can see that around 8 will be our smallest y. If we want to look at the table closer, we can use our table set, which is second and window, have the table start at 8.15 and count by 0.01. And according to the calculator, the minimum is 8.18, so it's verified. If we want to use the var feature, we see that Q of 8.19 is about 0.33, which is close to what we have here. Next, we want to graph the function. The window settings I'm using is -20 for x-min, and I want to go up to 40. I want to count by 5. For the y-min, I'm going to -10. The y-max is 40, and again I'm counting by 5. And here we see the parabola. If we want to verify the vertex, we can hit second and calculate, select minimum, number 3. Then we select a lower bound, so that's a point to the left of the minimum. Hit enter. Then select a point to the right of the minimum, and you will see these two little triangles, and we want the guess to be in between these two triangles. And then when we hit enter for the guess, we see that the calculator has given us a minimum at 8.18, and the y value is about 0.33. Number 4, define the miles in 2010. That implies that t is equal to 30. So we substitute 30 into the model. We get 22.7. If we did it by hand, if we use the graphing calculator, we hit y vars, select y1, and then put our input of 30, and we get an output of about 22.7. Number 5, Q of t is 25, so we substitute that in for the model, and then we need to solve for t. Our first step is to subtract 25 to both sides, so this equation is equal to 0. Now we can apply the quadratic formula. This is our value of a, this is our value of b, and this is our value of c. Plugging these values in the quadratic formula, we get t is approximately equal to a -14.71, which is outside the domain, or we get t is greater than 31.09. To see this on the graphing calculator, this is the point of intersection on the left side, this is the point of intersection on the right side. This line here is when y is 25. Using the intersect feature just to verify these answers are correct, the calculator is telling me the point of intersection is a -14.73 and y is 25. For the right one, x is 31.09 and y is 25. So we have verified graphically the answers to part 5. Thanks for watching.